Welcome to this tutorial where I will walk you through building a recommendation system using PyTorch. In this project we will create a collaborative filtering model that learns from user item interaction data like movie ratings or predict or product preferences and make personal recommendations. We've structured the application for simplicity and modularity, separating data loading, model building, training, and prediction into different components. By the end of this video, you understand how to design and implement a powerful recommendation engine using machine learning techniques. Let's get started. First, we need to execute a few commands in the terminal. This command will create a virtual environment that will isolate our Python project. It allows you to manage project-specific dependencies separately from the system-wide Python packages. This is particularly useful when working on multiple projects with potentially conflicts package versions or dependencies. The next command that we have to execute is pipe install torch and pandas. This command will install our libraries or dependencies, torch and pandas. Now we can start with the project. The first file or module that we have to create is DataLoader. Inside the DataLoader, we can start with the code. First, we have to import the libraries that we just installed. And additionally, a class the pandas dependency, this is actually a library used for data manipulation and analysis. The torch is the core PyTorch library that provides tools for creating models, tensors, and optimization routines. Torch should use dataset, a PyTorch class that helps manage and manipulate datasets, and the data loader that we have also at the end, a class that helps load data in batches, enabling efficient data processing and shuffling during the training and validation. Class. This is our first class that we have to write. I will create a command to explain it. This class is responsible for loading the dataset and providing data in a format that PyTorch can use it for training. our initial function that I explain. Well, this is the class constructor, which initializes the dataset when you create an instance of this class. The line 11, df equal to pd, reads the CSV file into a pandas data frame. This file is expected to contain columns like user ID, item ID, and rating. User ID, item ID, and rating, exactly. Next, we have actually df yes, actually. So what is happening here? Convert user ID and item ID into categorical indices for beta embeddings. So here, what we're doing actually, we're converting the user ID column into the categorical values and then assign unique integer. While we do this, we need a numerical representation of user and items IDs for embedding layers in our model. Converting them into categorical codes achieve this. On the second line here, it is the same as the previous step, but applies to the item IDs. Converting them converts the item IDs to integers values for similar reasons. And down below, stores the processed user IDs as an array of integers in the instance variable self-users, self.users, for later use. Next function or method. return the total number of samples in the dataset. The purpose of this method is to return the total number of data samples in the dataset for interactions between users and items. This is required by PyTorch Dataset class, as it helps PyTorch understand how many samples it can iterate to during training and validation. The next function or method that we are building, getItem. The purpose of this method is to retrieve a single data point when an index is provided. This is important. This method is critical for allowing PyTorch DataLoader to efficiently load data in batches during training. When the DataLoader requires a batch of data, it calls this method to retrieve individual samples. Decorator and the method. File path, batch size, we give a number, and then split. That should be enough. So why do we need that function? This is first of all the decorator. This decorator indicates that the method doesn't depend on an instance of the class. It can be called directly using the class name without needing to create an object first, like a static method. The get data loaders. This method generates and returns data loaders for both training and validation datasets. So, this method, actually we are invoking the class. In this particular case, we are creating an instance of the user item rating dataset caused by passing the file path. this loads and processes the dataset. Size, time split, and len dataset. Calculates the size of the training set based on the percentage split provided. In this case, 80% of the data will be used for training. Calculates the size of the validation set, which is the remaining 20% of the data set. Now here we are splitting the dataset into training and validation sets using the class. And we have to return the data loaders. Actually, that's true. So in the train loader, we are creating a data loader for the training data. The data loader automatically loads data in batches, which is more efficient for training models with large datasets. Shuffle 2 at the end that we have randomly shuffles the training data before each epoch to reduce bias and improve generalization. Val loader creates a data loader for the validation data. No shuffling is required for validation data because it will be used strictly for evaluation after each epoch. Data loaders are essential for managing how data is fed into the model. They handle batches, shuffling, and parallel data loading, making training more efficient, especially when working with large datasets. So with this, we are pretty much completed with the data loader class that we have with that module. And after that we can move to the next modules. And that is for now for this tutorial.